Hello and welcome guys to a new video. This video is dedicated to uh, basics of maths and calculus in order to understand further like Newtonian mechanics, classical mechanics, aka and other stuff related to physics. This is most required, tool you need to have in order to understand certain things in JEE main or maybe in NEET exam or maybe any other exam you give, any other competitive exam related to science you give it. So let's start with the first thing. First thing is set and elements. I'm gonna drop this PDF into my description box, and that will be useful for you guys. And you can download it and you can go ahead check it, go through it. This is from actually University of Sydney. Uh, okay, let's get started. Sets an element. What actually set mean is, a, I mean, a set of bottle, a set of glasses, a set of paper. Not a set of paper. I mean, a pile of paper actually. A set of a dinner set. You can say something like that, which has certain elements in it, and it is not no, and you have notation something like this, the curly bracket you can say up here right there, like something like this. So what is element is present into the set, and set contains element. All right, set contains element, and element could be anything. I mean, for example, it could be a name, number, or any whole number, natural number, real number, or integer. Anything could be, it could be anything. Then element is the primary or unit, you can say, of a set. Subset is the, for example, if you have a union set, for example, universal set, for example, you can say having 1 to 10 numbers. Subset is could be 1 to 3 or 4 to 6, or 7 to 8 maybe, including 9, 10, and all. That would be subset. Then equality of sets, for example, if you arrange 1 to 3 4 linearly according to their like synchronity, you can say they could be equal to 1342 or 1432, 43123, something like that. It would be always equal. It doesn't matter how you go. It's not a vector, like it's not a vector thing. It should be, doesn't possess any direction. For example, it doesn't have any something like 1 2, it should be 3 4. It can be, it could be 1432, it could be 2341, it could be 3124. I mean, yeah, you can have many probabilities. Absolutely, you can have many things. Then this is intersection, and this denotes union. Union means you're gonna be uniting thing. Intersection means you're gonna be subtracting thing which is not included. Natural number, a number, most of the people don't take zero as a natural number. It comes in whole number. I don't know why Sydney people actually took this thing as a natural number. Most of the people do take it. Well, this is natural number starting from zero. All right, we'll say zero as mentioned here. 1 2 3 to infinity. Integers are let me share my whiteboard. uh, so here we go. If we have something like this, for example, not this, a line maybe, you can say, pretty bad. In middle you have a 0 and 1 2 3 4, same as here. -1, -2, minus 3. So this indicates this is actually integers starting from 0. 0 indicates like a division point, a dividing point where it separates positive integers and negative integers up to spreading from 0 to infinity, positive infinity and negative infinity. So if you chop down this thing, for example, here, if you like here, you can chop down this thing, you'll be getting 2 by 3, that is absolutely equal to 0.666, 0.66. And if you chop down here, for example, very much close to 1, you'll be getting 0.99, which we can denote as approximately equal to 1. Oh, sorry, plus 1. This is 0.3 here. You can denote 0.3 here. It could be 1.5 between 1 and 2. And so as in on the left side. So this is the integer thing. And let's get back to our, oh, sorry. Then we have rationals, and addition, subtraction, and division of non-zero elements, you can say. Then we move on to the basic formula of a plus b equals c plus d or something like that, or a b equals cd. And then we move on to when and there is two rules actually when we add numbers. So we add number, like for example, if you add 1.2 plus 2.34, you're not gonna be, for example, you like for example, if I say, let me share again my white screen, whiteboard. For example, it's 1.2 plus 9, 4, or take it as 4.34. So I'll be getting 4, 5, 5.54. So whenever we're gonna add something, we're not gonna take this thing, because the smallest decimal point is this, is 1 decimal. For example, it's 1.2, so it's 1 decimal already. So we're gonna be taking only 1 decimal. So we're gonna be rounding this thing off to 1 decimal, that is 5.5. It's not 5.54. It could not be 5.54. Approximately it could be, but we always take this thing as right answer, because here यहाँ पर इससे छोटा, I mean you can't take anything. This is not equal actually. For example, this number is not that much accurate or precise, you can say, to this number. So that's why we don't generally add something like this and get something like this 5.54. We get 5.5 basically. That is the true answer, I mean right answer, you can say. That is during addition or subtraction. But when we multiply, for example, 1.2, 4.34, we take account of significant figures, that is mentioned here. I mean, let me share my screen again. For example, here a significant figure could be, this would be 1, 2, 3, 4, 5, 6, 7, 8. I mean, extending to like a lot of numbers. Then we have a pi, 3.14159, special number, irrational numbers which reoccur and they don't have a reoccurring number. For example, it could be uh, 2 under root 2, that is irrational number. Significant figures, yeah, we're gonna be mentioning significant figures soon. And for example, this here it is 26103. The significant figure would be 5. Here it would be 3103. We don't take this thing as significant figures because this, for example, if it is 3 point, we're gonna be writing this thing as 3.04 into 10 to the power minus 3. So we take 3.03 as three significant figures, and 10 to the power minus 3 we don't take it. So that is three significant figure in total. And this is 1, 2, 3, 4, and this is four significant figures. All right. So I hope you understand what actually significant figure is, because when I was in like lower classes, maybe 11, 12, studying for a NEET, I was unable to understand what actually significant figure is, and now I pretty much know what actually significant figure is and how to answer those questions basically, which doesn't come, but could be asked in JE mains or JE advanced, basically where you have decimal point answers and stuff like that. That is here accuracy rule for for addition and subtraction. When adding or subtracting numbers, the final answer should be quoted to the least number of decimal places that occurs least. Again, as I mentioned before, accuracy rule for multiplication and division. When multiplying or dividing numbers, the final answer should be quoted to the least number of significance that occurs. Again, least number of significant figures. You can say you can take an example. If 3.14 is, you can write 3.14 as 3, or as I mentioned before, this is 9.4 2.13 example, which is 11.53, which can be written as 11.5, which is right. You can't write 11.53. I mean, it's not you can't write 11.53, but yeah, most preferably it would be 1.11.5. All right. Multiplying, subtracting, again you have the same law, a rule. It's not a law, it's a rule. And then you again, for multiplication you have a significant rule. For example, 6.37, how many into 10 to the power 6, how many significant figure does it contain? Three significant figure. That we say, for example, a 1, 2, 3, we don't take 10 to the power 6 as a significant figure, rounded off. All right. It's approximation could be, we take for example, I'm gonna, if someone says approximate up to 2 decimal point, so I'm gonna 7 को मैंने यहाँ डाल दूंगा. For example, it could be 6.4, it becomes 6.4. all right, 6.4 10 to the power 6 meters. If someone says again you have to approximate up to 0 decimal, so I'll be taking only 6, not 7. all right, so it would be 6 into 10 to the power 6 meters. I hope you guys understand. I'll be putting this thing in the description box, that's for sure. And that's the basic things. And that's the whole idea, I mean, video all about. And as I mentioned before, I'll be using this book. It's lagging, I think. Yeah. For reference of any, I mean, sums and stuff like that. This is university physics. Calculate an approximate number of atoms in a bacterium. Assume the average mass of an atom in the bacterium is 10 times the mass of proton. Although you can solve this sum as if I take bacteria to be, for example, 1 gram. For example, if you have 1 gram of bacteria, that would be 1 divided by 10 into the weight of the proton. That would give me the number of bacteria, weight of the bacteria, or the number of atoms, you can say, not the weight, sorry. Then we have calculated the number of cells in a hummingbird, assuming the mass average cell is 10 times the mass of bacterium. Again, you can here it's on assumption. It's assumption. You have to assume it. It's not given actually, or maybe they have given. Maybe they have given in appendix. I don't think so. So you can follow this. I'll be giving this PDF too. Then again, you have pretty much everything sums coming up. Okay, all right. So I'm gonna show you guys all the sums. So I hope you guys do it. And if you don't, I've solved all these things. If you don't understand, or if you have any problem, you can message me. I'll help you guys out if possible. I'm gonna go slow, but because these things are the basics, and you need to understand it quite well. And only if you understand it, you'll be able to solve many more such things. So that's enough, I think. And hope you guys like it. And please do share it. And well, guys, see you next time.